Hello and welcome. This is the Additional Mathematics Form 4 Kssm discussion on the textbook question, Chapter 2, Quadratic Function, Intensive Practice 2.2. If you enjoy this video and learn something from it, so please like, and if you want to receive more notification when we upload a new video, please click subscribe. And also, if you feel that there's certain things that I can do to improve the video, please comment and give us some feedback. So let's get straight to this, okay? Now, the first question is determining the type of roots for the quadratic equation, yeah? So this is, I would say, rather straightforward and simple, yeah? You already know how to identify your ABC. Your A is 1, B is -8, C is 16. So when you do B squared minus 4AC, remember, B squared minus 4AC is called the discriminant. It is an equation used to determine the type of real roots. The types of roots. Right? If your B squared minus 4AC is more than 0, then we say that the equation has real and different root, or we say two different roots, right? Two different roots. If B squared minus 4AC is equal 0, we say that the equation has real and equal root, or two equal root. Okay. So, and lastly, if your B squared minus 4AC value is less than 0, we say that the equation has no real root. So now let me just go straight to the first one. So your B is -8. If you square it, you minus 4. A is 1, C is 16. -8 squared is 64. 4 times 16 is also 64. Now you notice this is equal 0. So we know the equation has real and equal root, or we can say two equal root. Yeah, just mention one of these will do. Yeah, two equal roots. Now the second one, actually you don't have to use B squared minus 4AC. Why? Because we can actually square root this, and straight away we realize that there are two possibilities, two answers. So x is now 2 plus minus root 3. So we can straight away say that the equation has two different roots. But if you want to show using B squared minus 4AC, we can actually expand it and write here x squared minus 4x plus 4 equals 3, x squared minus 4x plus 1 equals 0. My A is 1, my B is -4, my C is 1. By using B squared minus 4AC, I can find the type of root. A is 1, C is 1, so it's 16 minus 4, which is 12. Now notice the value is always more than 0, so we have two different roots, right? And for the third one, my A is 2, B is 1, C is 4. So when you do B squared minus 4AC, my B is 1, I square it, A is 2, C is 4, so it's 1 minus 32, 4 times 2, 16, 4 times 2 is 8, 8 times 4, 6, 32, 1 minus 32, -31, this is less than 0, so that we can say that the equation has no real roots. Alright, that is question number 1. I would say it's fairly simple. Question number 2, the following quadratic equations has two real and equal roots. So your B squared minus 4AC should be equal 0. Now you're supposed to find the value of K, right? So we know this is the general case. They are all real and equal roots, so equal 0. So first we have to rearrange this equation. Now remember, if you have a term with double x, yeah, you have a kx and 2x minus 2x, you have to factorize them first and put it together so that you can identify your B. Your A is actually 1, your B is k minus 2, and your C is 9, right? So in this case, when you do B squared minus 4AC, we know it's going to be equal 0. So k minus 2 squared minus 419 is equal 0. Now at this stage, right, I think most people, most students, they were trained to expand the bracket, right? Maybe I just show you two methods. The first method is, I know a lot of people tend to expand it, but I think it's a waste of time. I will show you another way, right? Instead of even expanding, do you know we can actually factorize this using A squared? You know that A squared minus B squared is actually A plus B. A minus B. So we can write this as k minus 2 plus 6, k minus 2 minus 6, because square root of 36 is just 6. right? So there are two possibilities. So k plus 4 and k minus 8 equals 0. Now you notice that what we have here is a quadratic equation that we can factorize in this form, and then we can just write negative 4 and 8. Now, alternately, we don't even need to factorize this way because we can just take 36. 4 times 9 is 36. You just bring it over to the right-hand side, right? So this will be positive 36. And when we square root, immediately we know there's a negative and a positive. So your k is minus 4 or 8. Now, I would say that method 2 is easier than method 1, right? Yeah, but again, it's up to you, up to individual. Some people would prefer to factorize it, and if you can expand and factorize also can, but this is, I would say even this method will be easier than expanding and factorize because it's a waste of time to expand and factorize back. Now, for B is a lot more terms, but it's actually more straightforward. My A is k, my B is 2k plus 1, and my C is k minus 1. Okay, when you do b squared minus 4ac equals 0, you have 2k plus 1 square 4ac, right, equal 0. When you expand, now unlike A, right, you notice part A, right, this term here, over here, is a number, 36. We can square root it. If your term here has unknown, you can't apply the same method as method 1 anymore because we cannot square root an expression with unknown k, right? So what we have to do is that we have to expand this. 2k if I square is 4k squared plus 4k plus 1. The negative 4 I times in is negative 4k squared. Negative 4k times 1 is positive 4k. The result is equal to 0. Now this equation may appear to be like a quadratic, but you notice that 4k squared and 4k squared, you can cancel it. At the moment you cancel it, what you have left is a linear equation, a simple linear equation that we can just bring 1 over and just divide it. My k is negative 1 over 8. Right, moving on to question number 3. So the following quadratic equations have real and different root. Find the range of values of r. Now, in this case, your b squared minus 4ac should be more than 0. Real and different root. So number 1, we need to expand x squared plus x, bring the rx over, bring the 4 over, let it be 0. Factorize this because we need to get your coefficient of x, which is b. We need to identify your b. Your a is 1, your b is 1 minus r, your c is 4, right? Now, when you do b squared minus 4ac, in this case more than 0, 1 minus r squared minus 4, 1, 4 is more than 0. Now again, this is the interesting part because a lot of people would tend to, again, expand and factorize. Okay, I want to show you another method, obviously. So first of all, let me just write this as 16, right, more than 0. Okay, first method is we can apply the a squared minus b squared method that I mentioned. A squared minus b squared is what? A plus b, a minus b. That will save us time to expand and factorize it. So I'm going to put a plus 4 here, and I'm going to put a minus 4 here. So this is now more than 0. So we'll get 5 minus r, and this will be minus 3 minus r, right? And it is now more than 0. So for me, I don't like this negative term. So I would, and you notice that we can actually factorize this negative over here, right? That is, I take out negative here. This will be r minus 5. And I can take out negative from the second expression. I get r plus 3. The reason being, a lot of people are more familiar with sketching positive quadratic, what do you call it, inequality, right? So you normally draw your a more than 0. So if a is less than 0, then we have to draw a frowny face graph. Now, not to say you can't, I mean, you must simplify this because your a actually, essentially, your a is still positive because it's negative 1 r times negative 1 r is still positive. It's just that most people probably prefer to put it in this form. Yeah, I just want to compare this because some people will expand and factorize, and then you get the slightly different expression, slightly different factor form. So that's why I factorize this to negative, and I just rewrite this as r minus 5, r plus 3 more than 0. Okay, so if you would expand this and then factorize it back, you will get this expression. And since you already learned how to sketch the graph of quadratic function, you know it looks like this. Your roots are minus 3 and 5. Yeah, more than 0 means the region should be here and here. So just move it down, and then we know that your r is less than negative 3 or r is more than 5. Okay. Now the second method is the one that similar to what I've shown you earlier. You want to bring the 16 over, right? And then from here, this is the interesting part about quadratic inequality. Now we can actually choose not to sketch a graph, but you just have to be careful with the inequality sign. We can actually square root 16 and get a negative and a positive term, right? Now you learned before in lower form 1 that for inequality, if you have, for example, negative x more than 3, whenever you transfer the negative over, right? Whenever you times and divide with negative number for inequality, the sign or the inequality symbol has to change. So likewise, when you square root, there's a plus and minus. The minus one, the symbol has to change, right? The positive part, the symbol, you just maintain it. So in this case, now we have to rearrange. I would actually bring this over, but I find that a lot of students find this is a bit confusing. They cannot see the sign. So I'll just show you the standard, the slower way. That is, I bring this over. I bring negative 1 over minus 4 minus 1 is minus 5. Minus 5, right? And when you change the symbol, when you times and divide with negative here, in this case you divide with negative if you like, you will get r greater than 5. And if I bring this over, minus r is more than 3. When you divide, r is less than negative 3. Now, can you see that these two answers are actually the same? Yeah, maybe I highlight for you this answer here and this answer here. They're actually the same. Two different methods, but same result. First method, you have to sketch a graph. Second method, you don't have to sketch a graph, but just have to take note of the inequality sign here. Be sure that you change the symbol here. Maybe I just highlight with this. Yeah, change the symbol here. Right? Remember that. Okay. I highlight the whole line for you. Okay. All right. So moving on to B. I'm going to bring this over. X squared plus x minus 2rx plus r squared. Yeah. Remember, your a is your coefficient of x squared. Although r has square, r is not your x, right? So r squared is actually your c, right? So please don't get confused about that, right? So this 1 minus 2r x plus r squared equals 0. So my a is 1, my b is 1 minus 2r, my c is r squared. So when you do b squared minus 4ac, the result again is more than 0. My b is 1 minus 2r, I square it for 1 r squared. Okay, it looks like I'm out of space. So just expand. The good news is I can simplify this further. I can cancel this r squared and r squared, 4r squared and 4r squared. So I'm left with negative 4r. I'll just bring 1 over. When you change the symbol, you divide it. R is less than 1 over 4. Okay. Moving on to question number 4. Find the range of values of p if the following equation have no real root. Okay, so meaning my b squared minus 4ac should be less than 0. Okay, the first one is you just have to bring the 2x over. Yeah, so you know your a, 1 minus b, you know your b, negative 2, and your c is 5. So when you apply b squared minus 4ac less than 0, your b is negative 2, you square it, right? A is 1 minus b, c is 5. This is now less than 0. So this is 420. Maybe I do a bit slower here. I just write this down for you. So 4 minus 20 plus 2b less than 0. This is negative 16. Okay, I made a mistake. This is 20 here. Negative 16 plus 20b less than 0. 20b is less than 16. b is less than 16 divided by 20 is 4 over 5. Okay, the third one again is already arranged for you, so it's easy. A is 4p, b is 4p plus 1, c is b minus 1. So when you do b squared minus 4ac less than 0, 4p plus 1 square, 4ac, my c is b minus 1, the result is less than 0. Expand 16b squared plus 8b plus 1. This is 16p squared minus a plus, plus 16 less than 0. Can we cancel them? Yeah. And you are left with 8p. Okay, there's a p here. Yeah, 16. Because this is 16p squared plus 16. 16p. So 8p plus 16p, that will give us 24p, right? Yeah. Okay, so this is 24p. 24p. Man. This is 1 less than 0. Just bring the 1 over, you get negative 1. I keep writing 2p. p is less than negative 1 over 24. Okay. All right, question number 5. Yeah. So this quadratic equation has two real and equal roots. So we know again b squared minus 4ac is equal 0. So to find the value of k, number 1, we can just rearrange this. Kx squared minus 10x plus 6k minus 5 equals 0. So my a is k, my b is negative 10, c is 6k minus 5. So when you b squared minus 4ac, yeah, the result we know is equal 0. b is minus 10, right? Square root 4, a is k, c is 6k minus 5, the result equals 0. So when you square this, you get 100 minus, okay, I'm going to times inside. This is 24k plus 20k 20k squared. This is 24k squared, 20k, no square for the second one. The result equal 0. Now, I don't like this number. I think the number is a bit too big. And yeah, we can divide everything by negative 4. 24, negative 24, if you divide by negative 4, you get positive 6k squared. 20 divided by negative 4 is negative 5. In this case, you have a k. 100 divided by negative 4, you will get positive negative 25. Yeah, 100 divided by negative 4, you get negative 25. So this is equal to 0. Now we have to factorize this. So 6 times 25 is 150. To get 5, I think I can use 15 and 1, 15 and 10. So to get 15, I must put 5 here. To get 10, I must put 5 here as well. So it's 15 and 10. This is minus, this is plus, because I want negative 5. Negative 15 plus 10 is negative 5. So my k is negative 5 over 3 or positive 5 over 2. Okay, I'm not done yet. The question says find the value, the roots of the equation using the smaller value of k obtained. The smaller value of k in this case is negative 5 over 3. Now, here I have two ways to show you. Number one, okay, first of course we substitute k inside your equation. So you get negative 5 over 3 x squared minus 10x plus 6. Negative 5 over 3 minus 5 equals 0. So most people will do it this way. They'll sub inside, okay, and simplify, right? These two can cancel, left with 2, so you get negative 15 here. Now I don't like this number here, so I times everybody by negative 3 and I divide by 5 to make coefficient x squared becomes 1. So this is positive x squared now. Okay, 10 divided by 5 is 2, 2 times 3, but there's a negative, so it's positive 6x. 15 divided by 5 is 3, 3 times 3 negative, so it's a plus 9 equals 0. So to find the roots here, we can actually factorize this and say that x is now negative 3. So the root is negative 3. Right? Now, I know some people may say find the roots. What do they mean by find the roots? Supposed to have two roots. They're actually two equal roots, because you can actually write like this: x plus 3 equals 0. So your x is just negative 3 and negative 3. So two equal roots, right? Now, method 2, in my opinion, is easier. But before you do method 2, I need to tell you about this formula: minus b plus minus b squared minus 4ac over 2a. Now, this is a quadratic formula, right? Now we know when you have two equal roots, your b squared minus 4ac should be 0. So if you let your b squared minus 4ac equal 0, what is left is your minus b over 2a. Correct now? So actually this is called your axis of symmetry. Okay, but that would be another lesson if I were to talk to you about this. It is a shortcut to find the roots using axis of symmetry. Now, I know my b, I know my a. Yeah, you don't even have to simplify the whole expression because you can see from here, this is my a, right? My a is just k. I know my b is negative 10. You can even look at the original function. Yeah, so I don't have to do all this thing. I just have to put my b inside negative 10, right? My b is negative 10 over a is negative 5 over 3. So now 10, okay, maybe I keep this 10 divided by 5. I know a bit hard for you to see. Some of you find this a bit difficult to see, right? So this is a 10 here. This is a 10 over 3. When you flip it upside down, it's 3 over 10 with a single negative. Because there are triple negative here, maybe I leave one negative here. So it's just negative 3. So we can actually sub inside the formula and get the roots straight away without factorizing, isn't it? Right? This is a shortcut to find the root of the equation. All right, moving on to number 6. Okay, we're supposed to express m in terms of n. Again, we have to start by expanding this expression. So I'm going to bring n over, m over, Malaysia over. I push the Nigeria in front to n, right? So your a is 1, b is negative 4, c is 2, n minus m. So when you do b squared minus 4ac, they say it has two real and equal roots, so we let it be 0. b is negative 4, I square it, a is 1, c is 2n minus m. The result is equal 0. So 16 minus 8n plus 4m equal 0. Okay, so what I need to do is to transfer all the rest of the term to the right, because I want to find Malaysia, yeah, m. So just divide by 4, I get 2n minus 4. Yeah, I think this question is pretty simple, right, compared to the rest. Okay, moving on to question number 7, right? A quadratic equation, right? X squared plus bx plus c, where b and c are positive integer, has discriminant of 16 and b minus c equals to negative 4. So find the possible values of b and c. Okay, number 1, discriminant is your b squared minus 4ac, and it's now 16. As you can see from here, your b is the same, your c is the same, only that your a is now 1. So we can just substitute a with 1, right? And therefore your b squared minus 4c is now 16. You can call this equation number 1. Now my second equation is b minus c equals negative 4. Maybe we should use substitution. I bring c over, bring this over, c is now b plus 4. Equation number 2. As I sub 2 in 1, your c is now b plus 4 equals 16. Expand this, b squared minus 4b minus 16 equals 16. So when you bring this over, you get negative 32. Now we can double bracket factorize this, b, 8, 4. To get negative 4, 8 must be negative, 4 must be positive. So b is either negative 4 or positive 8. Now take note that b and c are positive constants, so we can just straight away ignore negative 4. We take b equals 8 as the answer. And when I sub inside equation number 2, my c is just 8 plus 4, which is 12. Alright, next I'm finding the corresponding roots. Okay, now again you can use the concept that similar to question number number 5 earlier. We can take b and c now and substitute into the original equation. My b is now 8 and my c is now 12. So immediately I can factorize this, x plus 2, x plus 6 to get 8. So the roots should be negative 2 or negative 6. Yeah. Ultimately, you can use minus b plus minus square root b squared minus 4ac over 2a. Now, you don't even have to, to simplify all these things, because you know my b I already know is 8, so I just put 8 inside. My b squared minus 4ac, my discriminant, is given as 16, so I'm just going to put 16 here. I know my a is 1, so this is minus 8 plus minus 4 over 2. But I know some people say this is harder because you have to like work out two separate values, whereas factorization may appear to be easier in this case, right? So it's minus 8 minus 4 over 2 and minus 8 plus 4 over 2. Minus 8 minus 4 is minus 12, divided by 2 is minus 6. Minus 8 plus 4 is minus 2. Minus 4 divided by 2 is minus 2. So see, you are getting the same result but using two different methods. Okay, lastly, number 8. Yeah. Okay, we are supposed to find the two possible values of c, that is c1 and c2, given that this equation has no real root. So there are many ways you can look at this later on. I'll just show you the shortest, the easiest way you will do, right? So b squared minus 4ac we know is less than 0. B is negative 5. Okay, I think I don't have to mention ABC right now, right? Okay, A is 2. My b is negative 5, my c is just c, all right? Your a is 2, this is c, less than 0. 25 minus 8c less than 0. Now I'm going to bring this over, you get negative 25, right? Whenever you times and divide, you change the sign, right? So this c is more than 25 over 8. Okay, now 25 will be a bit hard for you to comprehend because you need to find two possible values, c1, c2. Maybe I change your mixed number. That will be 3, 1 over 8. Now, when you change your mixed number, you can see that your c value is slightly more than 3. 3, 1 over 8 is slightly more than 3. So we have to, well, take two possible values. Actually, you can take any value, but I'll just let c1 take the nearest one. The nearest integer more than 3, 1 over 8, it will be 4. And c2 will be 5. Now you're going to take other value also can. You can take 6, 7 and so on. I think the textbook answer at the back they use 4 and 5. Okay. Now based on the two values of c1 and c2, does this equation, now look at this equation here. Okay, maybe I highlight using this and compare with this equation here. Yeah. Does this equation have two real root? Explain. Okay, so now you don't even have to do any calculation, right? Because we know that c1 and c2 is already more than 3, 1 over 8. Sure enough, because these two values are really more than that. Now, what is half c1, c2? What is half c1 plus c2 represent what? Is the average, isn't it average? Average value of c1 and c2, right? Correct or not? So since c1 and c2 are both, yeah, greater than 25 over 8, right? Therefore, your half c1 plus c2 must be greater than 25 over 8. And if it's greater than 25 over 8, your b squared minus 4ac value should be less than 0. See, when, okay, let me highlight this. When c is greater than 3, 1 over 8 or 25 over 8, your b squared minus 4ac must be less than 0. c1, c2 is already more than that. So the average value is definitely more than that. So your b squared minus 4ac is definitely less than 0. So what can we say about the type of root? So we can say, does it have two real root? Answer is no. The equation does not have two real roots. All right, so yeah, that's the last question. Now, before you go, guys, before we go, all right, so just want to tell you about what we have to offer. We also have more additional mathematics form for modules, for learning videos with questions and step-by-step practice, okay, for you. If you're interested, you can find out a lot more about this, yeah, of our books and our module through our website, our calling us, or even our WhatsApp us, right, at the number given here. So thank you. I hope you enjoy learning from this video. I'll see you guys in the next video.